This is the 12th. It is 4/12/23. And today is more solving quadratic equations using square roots. So basically these notes get headed the same as yesterday's, solving quadratics with square roots. And it's easy to think like, well, gosh, why would we do this again? And as soon as we start working, you'll probably see why. It's not a lot harder today, but these, there are, I don't know, kind of depends who you ask, but there's a pretty noticeable jump in difficulty. Um, so there's going to be numbers in places that we're not accustomed to. My assumption going into this is that you were here yesterday and that you know how to do the stuff that we learned yesterday. That doesn't necessarily mean that you finished the assignment. It just means that you should be familiar with the process. So I have these numbered. I'm going to make sure I try to do them in the right order. So first example for the day, I have 6 examples, by the way, for your planning and preparation. So I already said that. You're right. Sometimes I repeat myself. I forget it when I say the things that I say them twice. Sorry. So this is going to feel just like yesterday's, and this will be really good for anyone who was gone yesterday. This is a nice kind of get yourself into the swing of it. That yellow thing, remember, has a name. It's called the power, and you want to get the power by itself. So whether you draw a little cute box around it or not, the idea is get that thing by itself. So the same steps as yesterday, we're going to add or subtract first and then multiply or divide whatever second. So if we add 13, what do we get on the right side? And then if we divide by 2, we wind up with, look at me skipping steps, we wind up with 5x plus 7 squared equals 23. Because there would have been a 46 there, but we divided it by 2, right? Anyone have any issues to this point? Bless you. So now it's time to do the thing we did yesterday, those 4 sweet words, square root both sides. As soon as you get the power by itself, it's time to eliminate the power. And the only way to eliminate a power is by using its corresponding root. So a power of 2 can be killed with a root of 2. If I square root this left side, remember, I just get 5x plus 7. And if I square root this right side, I get really nothing very exciting at all. But if I want to avoid getting yelled at right after the equal sign, I need to remember my little, that positive negative sign. And then what do you do with the square root of 23? Whole lots of nothing. Yeah, I would say break it down or try to take the square root of it or something, but 23 is pure trash. So you can't do anything, so we're just going to copy down root 23. And you should, if you were here yesterday, you should just totally feel like this is just exactly what we've learned. Like, why are we talking about this? It's what, could someone shut the door? Sorry, guys. I'm sorry. We should probably just do that always at the start of class, huh? Thank you. So it's what happens not in this next step, but the step after that. And so the new guy, if you haven't figured this out, I'll point to him, is the 5. The 5 was not there yesterday. And so he's going to create some division, and it'll create some worse issues as we go through the lesson here today. But step 1 is still to move the 7. Yes. Solid. So remember, when we move the 7, we want to very meticulously and purposely tuck it right where I'm pointing with that blue arrow. We always put the mover in front of the plus or minus. Like it used to be a positive negative, it becomes a plus or minus. We talked about that. And so I don't know if you could hear Jordan, but she said 5x equals -7 plus or minus root 23. And this is like where yesterday would have stopped, right? This was the end of the problem yesterday. The difference today now is we've got some division to do because x isn't by himself. So if I divide by 5, I get an answer that should look really familiar to you from something in our recent past. It's going to say -7 plus or minus the square root of 23 all over 5. And what does that make us think of when we just see that? That's total quadratic formula vibe. Like that whole number plus or minus root over a thing. That's, yeah. So that ought to look kind of like comfortable and familiar to you there. Any issues on that one? Okay. This one, I don't remember, but I think this one will feel the same. You're going to see some funky newness in the last four, but I think this one might be somewhat of just a rehash of that, what we just went over. So if you felt a little iffy on that one, hopefully this one will seal the deal, make you feel better. So notice this time there isn't a number that I have to move. There's just a number 3 that I have to divide away, right? If there were a mover number, it would be separated by like a plus or a minus. So all I'm going to do here is divide by 3. And that's the point where we have the power by itself. So now we have 3x plus 1. That quantity squared equals 13. And I mean, I don't want to say that's it, but really like this is just going to flow now, just like the last problem did. So we're going to root both sides. We're going to get 3x plus 1 equals positive negative root 13. 13 is another dead trash number that you can't do anything with. Move the 1. Right, so I'm going to wind up with x equals negative 1. So is that comfortable? If they were all like that, I would end the lecture right now and say, good luck, go do 20 of these. But they're not. There's some fraction-y sort of weird stuff that we have to talk about. And then there's also going to be the ones where the roots go away and we have to trace the plus and minus pathways and get like the 2 actual answers, like x equals 4 and x equals 5 halves. So that's kind of what's coming down the pike here. So number 3, example number 3 is 4 times the quantity of 3x minus 8 squared equals 4. Divide by 4, and we're left with power equals 1. Yep, 4 divided by 4 is 1. Okay. And then we're ready to do the thing, square root both sides. And so when I root the left, I get 3x minus 8. And when I root the right, I just instinctively put positive, negative. What's the square root of 1? Yeah. Right. And so remember, don't put roots on things that don't need roots. If that was like a 3, we would put root 3. But since the root of 1 is just 1, we're always going to pick the cleaner option. Let everybody get caught up to this step here. And what's the last step? Divide by 4. Right, and that's going to give us our not final answer.
Yeah, because you have to do the plus or minus route.
The plus and minus routes, the pathways. Good. I feel like it always takes time, but I feel like that message has finally gotten through to you guys that when the roots all go away, you've got more work to do, right? We don't want rational answers that can be expressed normally to be expressed like this.
So you would do 8 plus 1 to 9 divided by 2.
That's it. And so one of the pathways, I'll circle it for you, is a plus. And like Kennedy said, if you do 8 plus 1, you get 9. 9 divided by 3 is. So one of our answers is 3. Then you reboot, go back to the beginning, and you do 8 minus 1 is 7. So our other answer is 7/3. Yep. And so far today, no one is giving me this 2-point whatever stuff, and I really appreciate that you're learning well that when numbers don't divide, just leave them as fractions. I appreciate that. So that's what it's going to look and feel like a lot of times when all the roots go away. It's the same expectation as yesterday or any other day that you'll follow the pathways and split those rational answers out separately. Halfway point, still good? All right, the reason these last 3 examples are not the first 3 is because they all have fractions. And Yeah. So all I can say is just please speak up if when we get to the fraction part, like common denominators, just no one's going to make fun of you. You know that that's just not allowed, right? And so if you have a question, for God's sake, just ask it because chances are that someone else does too. So, yeah, but again, these are just you look at them and go, well, it's the same problem again, but they're not. They had all involve fractions. So, first one I have for you, this is example number 4, is this. This is a perfect little warm-up problem for the last half of the lesson because um, the fraction that's going to come out, it'll present itself right away. Like it's just there waiting for us. And you know already, I think you see where the fraction is going to come from. Because if we divide both sides by 4, then you're in high school, you know that 49 ain't going to divide by 4, right? So we're going to be left with the quantity of 3x minus 7 squared equals, yeah, it is what it is. So please start getting used to this idea that, you know, even though I don't think I or anyone has maybe ever asked you to take the square root of a fraction, it's actually really easy. So if I root the left side, I just get 3x minus 7. And then again, without thinking, I just put equals positive negative. Please do that before you move on to the math. Now, what do you think the square root of 49/4 might just be? Follow your heart. What's the square root of 49? What's the square root of 4? So what's the answer? That's it. Taking the square root of a fraction is exactly what we wish all math were that obvious and easy. You literally just square root the top and the bottom and boom, you're done. So what pops out now is a fraction, the result of square rooting a different fraction. And that's not to me what I'm not worried about that. That step's easy. It's this next part. So mathematically, you know what to do. You know you have to add 2 or add 7, right? That 7's got to move. So this is where the you know what hits the you know what, the fan. So we go 3x equals 7. Right. Step 1 is to worry about this. I don't know exactly what you mean by multiply it, but my issue is back in the day, someone taught you that if you're going to add a whole number to a fraction,
It has to be over 1.
you have to at least start by putting it over 1. So let's just say I took the math problem that's in that little red bubble and I wrote it over here as 7 over 1 plus or minus 7 over 2. This still doesn't do me any good. Why? That's not my problem. My problem is I literally can't add these together because they don't have a common denominator. And that's going to be the kicker for a lot of today's problems is I cannot, that's not Mr. Ahern being stubborn. I cannot add fractions if their bottoms aren't the same. So rather than writing that fraction as 7 over 1, in hindsight, I think I should have written it as 14 over 2. Because that still is a total net value of 7, right? 14 divided by 2 is still 7. But now I've produced it in such a way that its bottom matches the other one's bottom. The trick is, let me show you this because you're going to want to know this. Like, let's say I had the number 8, but I really needed it to be a fraction with a bottom of 3. What do I put on top? 24. Let's say I had a fraction of negative 11 and I really wanted it to be a fraction with a bottom of 4.
Negative 40.
I put negative 44. The trick is that you just multiply whatever the whole number is by whatever bottom you want it to have, and presto. So that was the magic that I used here is I took the number 7 and I said, well, I want you to have a bottom of 2 and you times 2 make ding 14. So where we're at in the process now is we have 3x equals 14 over 2 plus or minus 7 over 2. Are we okay still? Okay, now we're going to embrace the idea that if two fractions have the same bottom, we can add them together. We can also subtract them together. So my next step is going to say 3x equals 14 plus or minus 7 all over 2. No questions on that step? Nice. The last step is to divide by 3, right? Because we're not done. And what's fun about dividing fractions is really, if no one ever taught you this before, if you ever want to take a fraction and divide it by a number, you actually just multiply the number by the bottom of the fraction. So like if I was going to divide this side by 3 and divide this side by 3, watch how slick and easy this is. I just put x equals 14 plus or minus 7 over. Bam. Got a lot of 11th and 12th graders that see that for the first time. And I go, really feel sad that I never showed you that. When you divide a fraction, you really just multiply the bottom. It's pretty neat. Now we'll trace the pathways, right? So let's, I got some colors left here. I'll use a blue. If the blue is the plus, what's 14 plus 7? So 21 over 6 is one of my answers, but it needs some loving. Reduce that.
7 over 3, 2 over 3.
Yeah. And then the other pathway is going to be red, and that's 14 minus 7, which is 7. And 7 over 6 doesn't need any reducing. So those are my two answers.
7 over 3.
Neat, huh? That was where I stopped the lesson first hour. And then I realized 5-10 minutes in, like, oh dude, I should have hit a couple more. So that's, these last examples are inspired by my inability to do it right the first time. So this will be example number 5. I feel like if these go well, then I'll be able to cut you loose onto the homework and you'll have a much better grasp than those other guys did. Say again? Subtract 4. So we're left with 25 times the quantity x squared minus 3 equals negative 11. It was Bryce that inspired this. And when he asked this question off of his Delta Math, I thought that he had done something wrong. And that was when it hit me like, oh, dude, we got to talk about this. Because at first it feels like something bad's going to happen. Like there's a square and I got a square root and there's a negative. But you just kind of watch how this happens and it's actually pretty cool. So first, of course, we have to divide by 25. So we're going to be left with no parentheses, x squared minus 3 equals negative 11/25. Please note that there is no, if you were to put a plus or minus sign at this case, that would really mean to me that you're pretty lost. Like the positive, negative, plus minus sign doesn't come in until we square root, and we're still a little ways away from that. So what next? We can't. I would, for the record, if I could, but I can't. But I do need to add that 3, right? Because that x squared is called the power, and it needs to be gotten by itself. So when I move the 3 over, I'm going to, as always, I'm going to tuck it right there. So yeah, I have x squared equals 3. There's no plus or minus. Remember, the plus minus does not come into play until the moment you take the square root, and we are not ready yet. So how are we so far? Good? All right, so let's use our awesome new trick where we want to take the number 3 and make it into a fraction that plays nice with the fraction next to it. Well, I want the number 3 to be a fraction, but I want its bottom to be 25. How did I get 25?
No, how do you get it? You have to divide by 25.
I want this fraction. I'm going to put a blue box around this for you. I want this fraction to have 25 as its denominator because the one that it has to add to or subtract with also has 25. Does that make sense? For real? Okay. So great job there, Shanessa. So remember, the trick is you take the whole number and multiply by the bottom that you want it to have. And 3/25 makes 75. So I'm going to rewrite the problem, but I'm going to swap out the 3 for 75/25. And then I'm going to take away 11/25. Does that feel okay? It's at this point where the smoke really clears and you go, I see it. I get it. I know exactly what's coming now. Because what's 75 minus 11? So now I have x squared equals 64. And those numbers ought to be just really kind of making you feel good, because now what do I have to do? Oop. Square root both sides. We are at that point where we have to face that music. The moment you get the squared part, the power part by itself, the answer to what should I do next will always be square root both sides. Always. So when I square root the left-hand side, I just get x equals positive negative. What are we going to get? Yes. And you can type this into Delta Math actually as positive negative 8/5, because yes, they're rational answers, but because they're opposites of each other, Delta will take the positive negative sign. You can also, if you're more comfortable, type in 8/5 and then hit the little comma trick and then do negative 8/5 in the second box. It's up to you. I was scared of that one. How should I, was that not needed? Are you okay on that? Bad? Okay, let's do one more. For sure. So we're left with 16 times 1 minus 2x squared equals positive 1. And then what? And again, we're going down fraction road here, because you don't need a math degree to know that 1 doesn't divide evenly by 16. So we do need to keep our parentheses because the quantity is still a square. Yeah, and then the right side is just a fraction. Right, it's time. 100% time, because the thing squared, whatever it is, when it's by itself, green light, go square root. So when I square root the left side, I just get 1 minus 2x equals plus minus. You call plus minus, plus negative, positive negative. As long as you put it there, I'm a happy man. Positive negative, what? No. 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 Yes. You guys, your hearts were so in the right place, and I know that you tried to do the right thing. But remember, when you square root 1, of course it's 1, but when you square root 16, it's 4. You were thinking of maybe dividing by 2 or something like that. So we made it to here, and now we're kind of back to kind of old familiar, but it's a little scary because of where that minus sign is at. So let's see this one through, and then I'll be done for talking like this. We got to move that 1. And it is a positive 1, so we have to do minus. So we're going to be left with negative 2x. And I really am appreciative that you guys are very faithfully taking this number when you move it and tucking it just repeatedly in the correct spot. Great job on that. Do you remember the problem that we did? I think it was 2 examples ago, where we had something just like this, but we had 2 numbers. Look at the numbers on the right-hand side. What do we do when we try to add or subtract, but one of them's a fraction, one of them's not? You change the one that's not a fraction into a fraction. You always want to say, whatever whole number I have, I'm 100% sure I can write it as a fraction. So the number that I currently have is negative 1, but I want it to be a fraction with 4 as its bottom. So you times it by 4. And if the top is negative 1 and I multiply it by 4, what's negative 1 times 4? So this thing in the gold box, this is your prized possession. That's what you're going to go swap out for the -1. It's a critical step there that you get those to be the same. So we have -2x equals -4/4 plus or minus 1/4. And it's at this point, let me draw a cute little blue shape for you. I don't know what exactly it will look like. Maybe, I don't know exactly what that is, but it kind of looks like a little happy face. Like the plus is the nose and the, okay, I'll stop. It looks like a blue ET. So we're gonna leave the -2x, and then we are gonna blend the top as -4 plus or minus 1, and then put it all over 4. Does anybody remember the next step? Tenemos que dividir los dos lados por -2.
We multiply the top. We multiply -2.
Very good. Remember that we're trying to divide away the -2. And like Kennedy said, remember that when we're dividing, we're actually multiplying. If you make the bottom of a fraction twice as big, you make its answer half as big. Neat. So I'm going to take this -2 and actually inject it right there as a multiplier. So my final, not quite final answer is x equals, beautiful. And now it's time to just hope and pray if I make it this far. I don't want to botch the second grade arithmetic. Please help me. Here we go. -4 plus 1 is -3, which I have to divide by -8. What is the acceptable version of that answer? It is just +3/8. The only simplifying that would be necessary is just acknowledging that two negatives become a positive. Oof. -4 minus 1 is, which is, how we do? 6 up, 6 down. Your assignment, nice. Your assignment is on the old Delta Math. It's assignment number 29. Basically, with YTOP tomorrow, I'm just making the due dates on yesterday's and today's assignments just out there, like Sunday night or something like that. So don't worry about getting it done or anything like that. Yeah.